Welcome to Study Loop.
Problem 8.53, we're trying to find where between Pluto and its moon Charon the center of mass of the two is located. Now we're told the diameter of Pluto, the diameter of Charon, and we're told to assume that they have the same composition, and so their densities are the same. Now, as far as I know, we don't actually know what the masses of Pluto and Charon are exactly, or I even have really a good estimate for it. So this is not just the textbook being difficult. This is actually sort of a practical thing you might need to do if you know how big something is, which is fairly easy to figure out from observations, but you don't know how massive it is. If you make some assumptions about, in this case, the composition of the two bodies being the same, and so their densities would be the same, then you can actually figure out something about this. I believe you can also figure out what their center of mass is through observing their orbiting around each other, but that's not what this problem is about. So let's call this the x direction, just to have something to call it. And we'll put Pluto's center at 0, x equals 0, so that the x-coordinate of Pluto is equal to 0. And whenever you can do something like this, it will always make your life easier, because then one of the things is going to end up not mattering. So we know that the center of mass position, in this case we only have one coordinate x to worry about, is going to equal the mass of Pluto times its x position, which we've called its position 0, so that's nice, like I just said. And then the mass of Charon times position of Charon, which we know they're about 19,700 kilometers apart. So this will be 19,700 kilometers because we picked this to be 0. And then this will be divided by the sum of the masses. So we need to figure out what the masses end up being, of course. And as we know, the mass of an object is equal to its density times its volume. And assuming that they're little spheres, this is rho times 4/3 pi r cubed, but we're given the diameters and might as well just work with those. And that works out to be, well, so let's put them in a nicer looking order. 1/6 pi rho diameter cubed. Of course, all of this isn't going to matter because it's a common factor to all of these things here. So, but just for the, it's good to know these things. Anyway, so we have 1/6 pi rho diameter of Charon cubed, and then 1/6 pi maybe not make it look like pi as the denominator there. 6 pi rho times the sum of the cubes of the diameters. And so you see the 1/6 pi rows cancel out as promised. And, oh, I almost forgot that. And you put the numbers in, and we discover that the center of mass is 2,520 kilometers. And this will be from the center of Pluto, because that's how we set up our coordinate system. And now you can see that the center of mass of the Pluto-Charon system is actually outside of Pluto, because this is 2,370 and this is 2,520. So Charon is actually large enough in comparison to Pluto that the center of mass is, somewhere out here. And this is the fact of that Charon is basically comparable to Pluto, and it's not entirely comparable, but it's a fairly major sized thing compared to Pluto, as part of why when the International Astronomical Union, I forget the name of the organization exactly, but when they came up with an actual precise definition of a planet, this is part of the reason why Pluto is no longer considered a planet. It's a dwarf planet, along with Charon now, is because Pluto has not, quote unquote, cleared its orbit, which means that there's this other gravitationally significant object, and I think there are also some other bodies in Pluto's orbit that are large. I don't recall. Anyway, so that's part of the reason. So this is sort of hints at the reason why Pluto has not been considered a planet, since we developed an actual precise definition we could apply and decide on a case-by-case basis.